In this lesson, I'll show you how to solve a center of mass problem. The question reads, a 3-kilogram cat is in a 24-kilogram boat. The cat is 10 meters from the shore. The cat walks 3 meters towards the shore. How far is the cat from the shore? Assume that the center of mass remains constant and that there is no friction between the boat and water. Now, as we've learned in previous lessons, one way to calculate the center of mass is by using this formula right here. Notice that r is in boldface, which means that it is a vector, so it should have two components, x and y. Now, before we discuss this formula any further, let me give you an illustration of what's happening. Let's say that this represents our boat, and we have a cat that is right here. These are its whiskers. And according to the question, the cat is 10 meters from the shore. So the distance from here to the shore, I'll represent the shore with this line, is 10 meters. What's also important to mention is that the cat has a mass of 3.0 kilograms, and the boat, which I'll represent with capital M, has a mass of 24 kilograms. We don't know the distance from the center of mass of this boat to the shore. So I'll represent that as x sub b. Now, in the second scenario, the cat moves 3 meters towards the shore. So let me redraw that, where this cat is now closer to the shore. We don't know the distance from the cat to the shore after it has moved. All we know is that it has moved 3 meters towards it. So I'll represent that as x sub c with prime to show the after. And similarly, the center of mass for the boat, we don't know either after the cat has shifted. So I'll represent that as x prime sub b. With that being said, let me show you what this would look like if we were to put it on an xy plane. So on an xy plane, and this is important because when we deal with this formula, we're dealing with vectors, so we need to know the x and y components. So originally the cat is right here. Let's say it's at a point of 10 and 0. Therefore, it has an x component of 10 and a y component that doesn't exist. It's 0. So using this formula right here, we can say that the center of mass is equal to 1 over, and capital M here represents the total mass of the system. So in our case, it would be 3 plus 24. That's 27. And for this part of the equation, we have the sum of the mass of each individual object times where it is located. So starting with the cat, before it has moved, its mass is 3.0. And its distance, we learned, is 10, 0, or at this point. Therefore, its x component can be represented as 10 with this unit vector I plus 0 times its unit vector j. That's the unit vector for the y component. We don't even need to write that down. Okay? So that's for the cat. Now we have to do this for the boat. The boat has a mass of 24, and this gets multiplied to its location. We don't know its horizontal distance to the shore, and its vertical distance doesn't matter for the same reason it didn't matter for the cat. So I will write down x sub b I. So that represents this expression, the center of mass before the cat has moved. Now after it has moved, I'll represent that by r prime. Again, we have 1 over 27. The mass of the cat and the boat remain the same. And this time we don't know how far it is. So I'll write down 3.0 bracket x prime sub c, the unit vector I, plus the mass of the boat is 24, x prime sub b, I don't know this one either, its distance, times the unit vector I. According to the assumption in the question, we're told that the center of mass remains constant. So what I will do next is set both of these r's equal to each other. So I'll set this expression and that expression equal to one another. 1 over 27, I'm writing this one first. And 3 times 10 is 30 times the unit vector I, plus 24 x sub b, unit vector I, is equal to that side. Okay, now a few things we can do. Notice that we have 1 over 27 and 1 over 27 on both sides, so we can cancel them out. Okay, and we have the unit vector I in every term, so we can also ignore those moving forward. So we have our expression being 30 plus 24 x sub b is equal to 30.0 x prime sub c plus 24x prime sub b. Remember what we are looking for. We are looking for how far the cat is from the shore. So this is our target. I'll just double underline it just for reference. We can now represent x prime sub c as 10, which is the original, minus 3, that's the movement that it moved, the 3 meters, plus the displacement of the boat shown in this expression. So the after distance should be 7 plus bracket x prime b minus xb. To solve these two equations simultaneously, what I will do is I'll take this term over and also that term over so that I have the x sub b and x prime sub b on one side exclusively. So moving that over, I get negative 3.0 x prime sub c is equal to 24 x prime b minus 24 x b. Factoring out 24 from here and here, and of course on this side we have 30 minus 3.0 x prime c, 24 x prime b minus xb, and you'll see that this is the same as that. So bringing that over, x prime c minus 7 is equal to x prime b minus xb. Now taking your attention back to here, dividing both sides by 24, we'll cancel out the 24 here. So we're left with the same expression here and here, which means that we're getting really close to solving for x prime c, the distance after. That being said, I will make this and this equal to one another. Okay, now that that's done, take a look. I'll make this 30 and 24 into a fraction. It equals to 5 over 4, and 3 over 24 becomes 1 over 8 x prime sub c is equal to x prime sub c minus 7. So I'll take that over, take that over. Combining these and combining 1 plus 1/8 makes 9 over 8 x prime sub c. And over here, we have 4 as the common denominator, 28 plus 5. That's 33 over 4 is equal to 9 over 8 x prime sub c. And dividing both sides by 9 over 8 will give us our answer. And we get 7.3, repeating, as the distance of the cat from the shore after it has walked 3 meters towards the shore. And there you have it. That is how to solve a center of mass problem.